morning, good afternoon, good evening, wherever you may be watching this from. And this is Kenneth with another segment. Now, this is a continuation on parametric equations of a line into space. Now, we are looking at determining if two lines are parallel. So, like I said, this right here, forget about what I've done here, but look at it from this view. X is equal to that, y is equal to that. That is a parametric equation. This here is also a parametric equation. So what am I trying to say? These parametric equations, so this is a line. First of all, before you got the parametric equation, this is a line represented by L1, L subscript 1. Line 1, this is a parametric equation. This is line 2, represented by a parametric equation. You can represent a line by a scalar equation, by a vector equation, or by a parametric equation. So this is represented by this parametric equation. Now, determining if the two lines are parallel, first of all, let's write them in the vector equation form. X, y is equal to 2, 3, plus t, 2, 4. Then we have x, y is equal to 5, 4, plus t. Then we have our 4, 8. If two lines are parallel, this part of the equation is called the direction vector, because we said a vector equation is given by r is equal to r naught plus parameter t direction vector. So this r naught represents a position vector. This is the position vector in the form of a column vector. And then the parameter t, which is just a certain number that is used to change this direction vector. So it can increase the direction vector, or it can decrease when you're multiplying by fractions. Then this m is the direction vector, this part. So if two direction vectors are scalar multiples of each other, it means that these two lines are parallel. So we'll say 2, 4 is equal to k 4, 8, like that. What have I done? I've just got the direction vector here, 2, 4, direction vector here, 4, 8, 2, 4, 4, 8, and I have equated them. And then we'll do like we did when we were changing a vector equation back into a scalar equation. We get the top row. So 2 is equal to k times 4, which is 4k. 2 is equal to 4k, like that. And then we'll have, here we have a 4. 4 is equal to k times 8, 8k, 8k. So we have 2 is equal to 4k and 4 is equal to 8k. So it means 2 is equal to 4k. We divide both sides by 4. K is equal to 1/2. And then here we'll have 4 is equal to 8k. 4 is equal to 8k. We divide both sides by 8, like that. K is also equal to 1/2. So in values of k, since we have 1/2 there, we also have 1/2 there. When values of k are equal, it means that these two lines are parallel. That's how you determine if two lines are parallel. So if we had the direction vector, for example, let's say 1, 3, 1, 3, it means that if we were to erase what we have done, and we substitute it with 1, 3, This is the new parametric equation, 1, 3. It means 2 is equal to k times 1 is k, 4 is equal to 3k. So we have these two pairs of equations. So already from what we can see here, we have k is equal to 2 as a final answer. And then if we write that down once more, we divide both sides by 3. K is equal to 4 over 3. So the value of k for this one is 4/3. Then this one is 2. These values of k are not equal. It means that this and this are not parallel. So I changed the direction vector here, and then we got different values of k. I hope that's clear, and this is it for this video. Thank you so much for watching, and this has been continuous with another segment, and bye bye.